Okay, so in this video, we're gonna go over basically the main consensus algorithms that are currently in use today in blockchain and all types of cryptocurrencies. Um, so this is part of our understanding and explaining how DPOPS works and how we came to that conclusion and all of that. So it's important to first understand all of the components and all the other consensus algorithms. That way, you can understand why we chose DPOPS and like how we came to building DPOPS and all that. So the first one is proof of work. It should be the most common one to all of us. It basically is talking about you can go through all these and read these. I like this website because I used this. Obviously, I used more in-depth ones, but this was a good one to just kind of read through quickly to understand all the consensus algorithms. As I was doing research in, um, I think it was November, yeah, November 2018, a long time ago. So I like this website because it's real quick and it was really easy to just display to the team and kind of talk about it. So in proof of work, I think we all understand that one, but basically there's the hash of a previous block, your transaction hashes, your timestamps, other stuff in different blockchains, and then your difficulty, and then a nonce. And the nonce is basically the thing that all the miners are trying to find that satisfies the difficulty that's set currently. And the basic like idea of it is that it should be proof of work. It's expensive to create that block. Um, it's a lot of work to produce that block. It's not easy. You have to have hardware and stuff like that. We're going to talk about the comparisons of all of these in a different video because this will probably go about 10 minutes. So we'll do the comparisons and I'll show you some notes from an internal PowerPoint that I gave where doing my research in November basically figured out all the comparisons and the pros and cons, and we kind of just weeded through each one. So that's basically. I'm not gonna go over like what's good and what's bad about all this, but yeah. So it's just like a minute article. It's really simple. It's a good one to read. These are all good ones to read. Um, so then proof of stake kind of builds on that concept. Instead of it making it expensive, you have to have machines and stuff. It's just how many coins you have. You stake them. You can see different people have different amount of coins there. They put them in. It's into like a lottery system, and then they pick one, and if it's yours, you got that block. That's the very basics. Obviously, every crypto note or every cryptocurrencies change some things about that, but that's the very basics of it. That obviously this guy's going to win a lot more because he has a lot more. This is kind of the rich get richer type effect that um, people didn't like at all back in like 2013. If you look at the history and like around that time, before that time, most proof of stake coins didn't even survive because it was always rich get richer and all that. But now we have a lot of proof of stake coins, so it's just kind of interesting how things change in the space as we go along. um, I think one of the, again, we're not going to really get into it, but one of the things is it might be a little bit safer than proof of work at in different terms. So there's pros and cons to each one. So that's why we can see this one has taken off on some things. So then we're going to talk about DPOS, which is delegated proof of stake. It's the exact same thing as proof of stake, except for that you're delegating your vote to someone else. A bunch of people are voting for a person, and then that person then goes into the lottery type system, essentially. So and then they get the block reward, and then they can do whatever they want with it. Most they can give back percentage wise. They can just keep it. It's kind of like like we vote for representatives each state in the U.S. and then they go to Washington and do bills and stuff like that. So it's kind of a elected type, elected vote type of system. And then DBFT. This isn't really this is an add-on to me. Like you have to have one of those, and then you can add this into it. So there's some things. There's just some concepts and stuff that you can add on top of those three, but those are the basics. Like you have to have one of those. I know there's more than just those three, but this cannot be by itself technically. It needs to be on top of one of those consensuses. Basically, this one's a little bit more lengthy because DFT is a little bit more lengthy to understand. You can also read a computer science paper about DBFT because there's many of those. There's some videos and stuff too. But essentially, if you want a 30-second explanation of this, basically what's happening is it elects. There's people that have been elected somehow. So we can take it for example on our blockchain. You got the 50 people. They've been elected through DPOS. So now those 50 people, of one of them in there gets elected again, referenced as the speaker. We don't reference it as that, but that's what this normally is. And then they're the one that actually puts the block together with transactions and stuff. And then they kind of relay it to everyone else. So everyone else, okay, here's what I got. And then they have to basically vote. If most of them come up, well, what they do is each one has to, if you see this guy, he has to broadcast it to him and to him. And then this guy broadcast it to him and to him. So essentially, in a one-liner, DBFT is when you get data or you create data, you have to send your data to everyone, and then everyone has to send their data to you. So this is why it's message heavy, and this is why it's also a lot of coins aren't really don't have a lot of participants because there's a whole bunch of messages. The more participants you have, the more exponentially the messages go up. So essentially, it's 67% agree. Then it's a good block, and we move on. And then it just talks about how it's a fall through because the dishonest speaker, but these three are good. One of these guys are bad, but then these two are good, so it covers it. And then basically they can both, the speaker and one of these guys, but then these two can cover it. So it basically just explains it. Just remember on this one that basically you get data or you create data, you have to send it to everyone. Everyone sends you their data. If 67% agree, we move on. If 67% don't agree, we revote, we restart the round. So that's basically it for this video. It's just a basic explanation in my words of how these work, and then with articles that are really easy that everyone can digest in a quick manner. And then that should get you ready for the next video that we're going to do. We're going to talk about the pros and cons of each of these and show an internal PowerPoint that I did. So that'll be next time's video. So thank you for watching this video.